All right, we're on page 190, if you will. I almost have the test done. I'm getting close. Because the ones in Menominee aren't on paper, I have to grade them a little bit differently. But I was pleased with the results. I know you guys weren't perfectly pleased, but I think you did a good job. All right. On page 190, it gives us this graph right here. So the first thing that we did yesterday is we kind of sketched that graph, and we're looking at making some decisions about it. So what we're doing is from graph to function. I'm just checking. The only person missing is Gavin, so when he gets here, I just don't like that stupid door locking business. Okay, so in our notes, we're going from graph to equation. Step 1, find a horizontal line that crosses all sections of graph. Now, what do I mean by that? Well, if you notice that one on page 190, on that graph on page 190, if I made a horizontal line down here, it wouldn't cross any part of the graph. If I made it right here, it'd cross those two lower hoops, but it wouldn't cross all four parts. So really, I can't start my line until I get to here, right? And then up above that, I can go a little ways. I can go all the way. I could even go up to 70, right? And I'd still cross all portions of the graph. But anything above that, I wouldn't cross it either. So on my paper here, I'll show you. So we've got the sketch. So the first thing we're going to do is determine, well, where are we going to make our horizontal line? Now, that's backwards. Now, they made it right there. Let's look at the graph and figure out, why did they make the graph right there? What do you notice about all four of those dots?
We're all at 50.
Yeah, you see that? This one is at the intersection of these two. This one is at the intersection of these two. Can you close it all the way now, Gavin? Everybody's here. This one and this one. Okay? So step 2 would be, if possible, have horizontal where all sections are at an intersection. Okay, step 3. Pretend that horizontal is the x-axis. Okay, so if this line here is the x-axis, what are the addresses of those 4 points? Well, this is 0, comma something, this is 0, comma something, this is 0, comma something, and this is 0, comma something. Everybody agree with that? What number vertically does that first one match up with? On your graph. What? The very first one? No. If that's going...
Oh, are you saying the 11 is what you're saying?
Oh, I'm sorry. I went the wrong direction. I should have said something, comma, 0. My fault. Something, comma, 0. Yeah, so it's 11. What's the next one?
13.
And?
17.
And?
20.
20. Now, here's an important truth of math. Zeros are opposite of factors. So, 11, comma 0 corresponds to the factor x minus 11. So 13, comma 0 corresponds to
X minus.
And 17, comma 0 corresponds to x minus 17, and 20, comma 0 corresponds to x minus 20. So, step 4. Write the factored form. I forgot, what did they want us to call this? F of x? It's kind of boring. So we are on number A there, where it says find a formula for the polynomial function f with all the roots at these t values. So let's write it down. F of x equals x minus 11, x minus 13, x minus 17, and x minus 20. Now, you know what? I just thought of something that you might say, Kevin, why do these work out the way you have them? Like 11 is x minus 11. Okay, I'm thinking of a number that when I take away 11 from it, I get 0. You see why the number has to change signs? Because it has to be a number that you can subtract whatever from it to get 0. So it's 20 minus 20 is 0. 17 minus 17 is 0, and so on. Okay? So, this is a test question. Step 1 of our test question. We'll get a color here that will make you say test question. What is the highest power of the polynomial? X to the... Well, let's think about it. You're going to take this times this. What power are you going to get? X squared. Times this. Times this. So is there a quick and easy way to figure out what the highest power is? Equals... Good. Number of factors. Or the number of crosses. Right? So we go back here. Oops. We crossed here. 1, 2, 3, 4. Right? What's a turning point? Another test question. The number of turning points. What's a turning point? It starts going in the other direction. Is 1 less than the highest power? One, 2, 3. So you think about it. You're saying, okay, here's the river. Okay, I am going to cross the river 4 times. Okay, there's 1 time. In order to cross it again, what do I have to do? I have to turn. Let's count them. That's 1 time I turned, and now I have crossed twice. Now what do I have to do? And now I've crossed 3 times, and I've turned twice, right? Now what do I have to do? How many times did I turn? 3. How many times did I cross? 4. Got it? That test question is answered incorrectly by about 40% of the students. Don't know why. So, we've got the factored form. Page 190. It says for part A, you may leave your answer in factored form. Why? Because it doesn't do any good to multiply it out at this point. So, let's go to Desmos and let's do it. So we're going to make a graph, page 190, Pierre's graph. Okay, we're going to make a graph, and it's going to be of the form f of x equals, parentheses, x minus 11 times x minus 13 times x minus 17. Ooh, one of us made this not right. Times, what did I do? Times x minus 13. What? Times x minus 17 times x minus 20. Okay, it's not Kevin, it's not appearing on my graph. Why is it not appearing on my graph? My window is screwed up, right? Notice my window doesn't even start till 20, so let's go from x going from 0 up to 25. Oops, 0 up to 25. And then my y, let's go from negative 50 to positive 100. And I'm going to show you why in just a second. Ooh. Negative 50. Did I get my factored form right? What did I do wrong? Oh, I know why. I better go negative 100 to positive 100. I have 2 more steps left to do. Negative 100 to positive 100. So, does that graph match the graph that's in your book? Well, it's got the right number of turning points, correct? So we're pretty close. Let's go through the rest of it, and let's see if we can figure out how to get the rest of it. Part B. Pierre's function has 1 local maxima and 2 minima and 2 local maxima. Using a graphing calculator or app to examine the graph. Choose a viewing window so that you see everything from 11 to 20. Now, they do it differently than the way I teach it. In your notes, let's look at this graph. And we're going to talk about the right hand behavior. The right hand behavior says, if you are ending going down, the leading coefficient is negative. If you are ending going up, the leading coefficient is positive. So do you see that Pierre's graph ends going down, correct? So in Desmos, where'd it go? What happened to my... Oh, there it is. In Desmos, if we put a negative in front, do you see what happened? So, we are up to how to graph step 1, 2, 3, 4, right? Step 5. Get right hand behavior. Now this doesn't just work with polynomial functions, this works with any function. If it ends going up, it's going to have a positive, and they call that leading coefficient. So let's get the test question for this. TQ. The leading coefficient sign is the same as the right hand direction. Okay? So if you have negative 3 x to the blah, 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 the graph is going to go down. If you have positive 1.86 x to the, it's the right-hand behavior is going to be up. That's different than the way they explained it, okay? If you look at the way they explained it on that page, they said, go by which direction the turning points are. Well, if your first turning point is going to be down, okay, then you have to start by going up. So when you cross the river, if you know that when you cross the river you're going to end up going west, you better start on the east side of the river. I don't know. It just seems like a dorky way to explain it compared to just go by the leading coefficient. So now we've got our graph going in the correct direction. It says, call this modified function g of x. So I'm going to take this negative sign out. And if you notice, oh, Christmas tree, it kind of does look like a Christmas tree, doesn't it? Christmas is coming, the goose is getting fat. Okay. You with me so far? Part C, number 6. Scale the function. Okay? Here's the real. Here's the model. Here's how you scale the function. Okay? How far apart is the top from the bottom on their graph? How far is it from here to here? 60. On your model, I'm gonna just not show the red one right now so that we get them going in the correct direction. How far is it from the top to the bottom? Now, what's neat about Desmos is that if you click on it, it will give you the addresses. How far apart is it on your model? From the top to the bottom. 41 down to negative 80. How far is that? 120. Okay. Oops. So on your model, from the top to the bottom is 120. So what do you have to do to your model to get it so that it's like the real thing? How can you scale it? Multiply by 0.5. So let's take and it says call it H. So let's take our graph. Oh, the most popular wrong answer is positive 0.5. You still keep the negative in there, 0.5. What just happened to our graph? It went from 120 from the top to the bottom to 60. Does everybody agree we now have scaled it correctly? Okay? So it's scaled correctly. Last step. Let's see. Maybe, Do you need better directions on how to scale?
Yeah.
Scaling factor. So here's your scaling factor. How about write it as a ratio of the real divided by the model?
Kevin, can you explain what the real and the model is again? So the real is the graph, like the...
Okay, so on your paper, write this one right here.
Yeah.
Call this one real. And maybe I'll sketch my model. So for each step, I'll sketch my model. Let's see. So I can't remember exactly, but my model looked, for this first one, it looked something like this, right? It went down and then up and then down and then up.
Okay.
And then for my next time that I drew it, this was f of x. This was g of x. It went up and then down and then up and then back. So each one of these is my model. Here's my model. So now I didn't sketch the whole model, right? But now that I did, I can call this h of x because it goes up. It goes up half as far, down half as far, up half as far, and then finishes.
Why would you want that?
Okay, well, let's go back to our graph and see. This is what we had. Okay? It does not match our real function because it goes up too high, it goes down too low. Compared to the graph that you've got on page 190, right? The graph on page 190 goes as far up as this purple one does, correct? It goes up and comes back down. This distance in the purple is 60. This distance in the green is 120. Does that make sense? Everybody good? Last thing is we have to take our model, step 7, shift the output. In this case, we want the real, those dots that we had at the beginning were not at 0. They were, y wasn't at 0, y was at 50. Where our model, y was at 0, correct? So we have to take our model and we're supposed to call it, I must be off by a letter, because they call it h of t. Anyway, we have to shift it up 50. So our graph now is going to go through 50 up. And now our model matches the real. Plus 50. Okay? Does that match what's in your book? Well, if you notice, the peak, does it look like it's at 11 and 70? No, I'm sorry, almost 12 and 70. And then almost 15 and negative 10, or and positive 10. And then almost 100 and about 19. Ooh. I didn't even notice that you weren't here. Oh, woe is me. Everybody good? Does it match your graph on that page? You are going to use the 7 steps to graph this thing here. Oops. I made a red line on my graph vertically to show where 0 is, because usually we make the x or the y-axis to be an important part of the graph. If you notice the way they drew it, they have negative like 2.5 as being important. I really don't care about negative 2.5. I care about the x-axis there. Okay? Go through the 7 steps, work as a team, find your answer. 5, 4, 3, 2, 1 on how good you're going to do on this. 1, 4. Looks like the 1s better work. 2, 1, 4. Got enough in that group that don't know what they're doing. We got a 4 over there. How about your table back there? We got a 2. Uh-oh. Uh-oh. Looks like Kevin's going to be intervening in that table. Menominee, what you got? 5, 4, 3, 2, 1. 3s. Somebody lacks confidence. Ooh! Who's sitting there with the stocking cap?
It's me.
I don't know your name.
Brad.
Okay. So make sure you work together and get that done. On your mark, get set, go.
I don't know anything. Just red lines in my book. That's okay, right there.
Yeah, that's what I'm doing.
I think we're looking at this guy. Yeah, so it doesn't have to be this.
Where all the points connect.
Yeah, essentially.
So I was thinking this line right here, the 10 or whatever it is.
And that's still
Make it Thursday right now. So I'm trying to do it. I didn't even make it for Monday. I just did 2 classes on Monday.
So then pretend that this is the x-axis. So
what are we saying?
-1.
What I don't know why that is that's not what you need in high school.
Wouldn't this be, this is the x-axis.
I do.
No, like this is a new x. Oh, yeah.
Because I have a high school student who's all in that.
So,
That's why I got all
Zero,
that
negative
students.
love it. No, for like, you got like,
You did
high
high
school,
school,
we
they
kind
just
of
like,
have
I'm so
this
stupid.
now we got like 11
I
and
can't get
0.
over and do that class. I'm like, well, you're past college math for me right now. So we yesterday,
I'll play that.
we play Xbox, so after 1% got my own controller, so they play, and then they die, and switch back to my controller playing, and then once I die, they switch back to and then I ordered dominoes.
Finding our,
That's how I yesterday went.
That's
Hardest thing I've ever done.
yeah, just keep the opposite way.
I'll be like,
How did we end up getting 11 0? Like we pretended this was the x-axis.
To me, the magic is knowing where to draw your horizontal line. Did anybody get the perfect horizontal line?
Right here, I did.
What did you get?
We just did at the 10. I don't know if this is alright.
Is that the perfect line?
I think so. I think it's pretty perfect.
Raise your hand if your group did the y equals 10. Woohoo!
Is that right?
It is.
Woo! Get it on.
Okay, which are you supposed to compare to another graph?
You have to come up with an equation for that graph. Right there.
Guys,
That's why you need decimals.
That's
Very difficult.
well, now this is the x gives you the x minus
You
like.
got x
So
cubed.
what are you going to have for your point?
I don't honestly don't.
Minus
Nope.
1.
X plus
Plus 1.
So
Change the
one
sign.
x
minus.
This is my homework, so.
Alright, yeah.
So that's ours.
Yep, that'll be x minus 1 is the second one.
X minus negative 1 and negative
Yours
1.
You gotta do the opposite.
So how many factors do you have?
So x minus.
How many turning points do you have?
Negative.
Nope.
It's a
Times where you turn around.
Would it be x?
It'd be x plus
Well, I don't get
Where
it.
does the graph turn around? It was going up. Start on the left-hand side. It was going, when did it stop going up?
Get the 10.
Keep going further. Right there, it stopped going up and now it starts going. And when did it stop going down?
It's saying 11.
And then what did
Oh,
it do?
so like
It turned around. I know I'm looking
At the
at
right
it.
hand behavior, we're going up, so it's up to negative.
I don't, I got like partway through, I did not change the test score yet. Or something. There's something that I'm working my way through and I have not done it yet. Whatever it was. Yeah, I haven't done it yet.
You added
I've been wanting hot chocolate for like the last 8 years.
Hey, hot chocolate is not a topic for discussion right now.
Yeah, we're talking about Christmas.
Whatever
trees,
it's scaling,
yeah, we're talking about Christmas trees and trees in this class. I don't really know where
That's what you
my
just
mindset's at.
You just added
Kevin's
negative.
got a beard and he's wearing red, so.
To make it turn around. Right? To make sure you get the turning point in the right direction. No, this turning point is not negative. And this right hand behavior is not negative.
That's how you do it?
Do you want me to do my notes?
Okay.
Yeah, because I don't
You might want to take a picture of my notes then.
where the little dots are. So you have to flip.
Guys, how's our right hand behavior going?
It's like right here, now it's just.
Yeah, we got that. How's the
We're
scaling?
for right hand behavior.
Are we not there yet?
Right hand behavior means the right hand end of the graph.
Did you guys do the right
If
hand?
it's going
So it's a
Y'all did the right hand.
so it's positive. And it's
It's
automatically
positive because it goes
positive.
up.
The graph is automatically positive.
So.
Have you guys started
Yeah,
doing this in
and then so if
decimals
this
yet?
went down, it'd be negative. But this
Because you should be starting graphing it in decimals. As soon as you get the factored form, graph it in decimals. So get out your phone or your computer, graph
What?
it in decimals.
Are we like doing the equation?
You know what they're doing?
Yeah, so you have the equation, f of x equals that. But with the right hand behavior, with this going up,
Yeah, no,
it's
graph
positive.
that.
So there's gonna be a positive number in front of that equation.
I think
Oh, it's to figure out
Just
this.
get the last factor.
Oh.
yeah, just like the. So for this one, it would be like.
Okay, so take out your decimals and graphs. F of x
I don't
equals
know, bro, but
Yeah,
that's all
go
right.
ahead.
f
Right,
plus
yeah.
1, f minus 1,
That
f
is our-
minus 2. I'll use your computer.
I'm motioning my hands up all the
Yeah,
time.
the way that
That's stressful and stuff.
I mean, I like using my left.
How far?
Does it go in the right? Does it end in the correct direction?
right.
And then in your, so the model and the real both are going up. So you don't need to change the direction.
Do you just then put these around?
Now we have to figure out how far away the top.
You mean to make it, if it ends down, I put a negative sign at the very front.
And that.
If I needed it to go down, I put a negative sign at the very front.
I got some decimals for this.
But I don't need to in this case because it ends off. Correct?
So we don't need to add.
Right.
So
We don't
from
need
this
to end
point
negative because
So
we're
how
ending up.
come it has to be 10?
Look at the graph that we
Or
did.
y intercept.
Which direction did it go? That one right here. Which direction did it go?
Let's say.
Okay.
That's why we do it in negative. No. We're doing this right hand page there.
So scale.
We're graphing that in decimals. Did you graph that?
Yeah.
I did that.
Do
I
the,
don't know how to do it either.
why is, Nicole, you gotta explain to her why it's not negative.
He'll explain it.
Well, make it negative and just see what happens if you put a negative sign in front.
I'm just like trying to find the reasoning behind it.
Okay, just a second,
I'll
Sam.
let's.
Very
We
good.
already just wait till you
Did
hear
you
it.
even know?
Alright.
Look at that. Look at that color coding skills. Yeah.
Yes.
I was just wondering if
Do we
this
not need to do the
looks approximately like.
What's the height, bro?
I just supposed
It's
to.
not gonna be,
That one.
it's not gonna be 4.44.
Okay. I just
How far is it from the top to the bottom on here?
It's
About a little
2.113.
over 20
Like 21.
Wait, what's this one?
to about 7.
That's
It's
height.
about,
The difference.
about 14 or so, 13 or 14.
Yeah.
How far is it on your graph?
Um, take that out.
But I thought it was 20.
Okay.
Because-
No, he like
Yeah, scale it.
scale function.
Because of
Yeah,
this is
12
Oh, I don't have the scaling right. That's why.
to 9.
Oh, that was.
Can you scale
That's
it?
almost like
Okay. Because that's how we're gonna find the points. So we can find the difference in height.
2.
French doesn't all.
This is so good.
0.63.
So how far is that?
I'm not trying to
Should we say 3? Or should we say 2?
Well, you look at, you put those two numbers in a ratio and see what whole number gets you really close to that. Because I can tell you the coefficient is going to be a whole number. Because they make them easy in here. In real life, your leading coefficient might be like 3.16842. But what number do you get close to? Madeline.
Okay. So we don't know how to scale it off of this
Okay.
so that we can find the height.
I don't know.
Because we
From
found
the top to the bottom, what do you have for the address?
It's like 4.6.
Of the
we have the top, the maximum point and the minimum point or whatever it is, but it's not scaled on decimals, right? So we don't know what it actually is or something.
you need to know the second number here and the second number here.
Okay.
Why?
And the second number here looks to be about 21.
So we're just
Sure, so-
estimating.
We are for right now. That's the best we can do. The second point here looks to be about 7 or 8.
Yeah.
Let's say 8.
Okay.
How far apart are those? 21 minus 8 equals 13, correct? Okay, now you go to your model. And your model is on Desmos, correct? Page 191. Okay, give me your factored form.
X minus 1. X minus 2.
Okay? In your model, your peak is at 2.113 and negative 0.631. Two 2.113 minus negative 0.631 equals. What? 2.74. 4, 4. 13 divided by 2.744 equals, make it a whole number. What? What did you say? And in real life, what did you get for an actual calculation when you did that? 13 divided by 2.744. What did your calculator come out as? 4.7. Okay. So in real life, we would have said 4.7 or whatever you just said. But they want you to make sure it's a whole number. Just for this class, they want you to keep it as a whole
So
number.
now we do it as 5.
So we do it to 5. So our next graph is going to be this. And this is the part that I think it was Felicia, somebody had a hard time with. She wanted to know, why would I put in a negative sign? Well, what she did to see why you put in a negative sign is she put in a negative sign and she said, well, that's not right. It's going the wrong direction, right? So that's how she knew not to make it negative. So she put in a 5 there. So now our graph got stretched out. So instead of being 2.744 tall, it's 13 tall. Let's just make sure that it's 13 from the top to the bottom. Let's say this goes from negative 5 up to positive 35. Okay, so do you agree that from there to there is about 13? A little bit more than 13, isn't it? About 13 and a half. And the reason we do that is in our real graph, in our real graph, you can't tell, is this 21? I mean, we estimated. Is this 8? I mean, we estimated, right? We didn't know those numbers exactly. Last step, how far do you have to shift it? What did you call your horizontal axis? So we shift it, we shift it up 10. Does it look like the one that's in your book? Oh, I don't have my axes right, correct? Why are we shifting it up 10?
Is that where all the dots are? Right?
That's when we started at the very beginning, we drew our line up 10.
Got it. Awesome. Perfect. I'm confident. I'm at a 5 right now.
Does it look close to theirs? And according to this, instead of saying 8, if we would have said 7, we would have been a lot closer. And it's not really up to 21. It looks like, according to this, it's up to 20.563. Since we didn't know the exact addresses of the turning points, we just estimated them. That's our graph. 5, 4, 3, 2, 1 now. Menominee, no fingers? Okay. Page 193. Optimization. Optimization. We want to make a cardboard box, cutout box, like you see in the picture, that holds the most popcorn. Interesting concept. We are going to... Actually, this took place about 2 years ago in real life, because it was, I think it might have even been Thanksgiving Day. that the following events actually occurred in real life. Ooh, here we go. Okay, you want to explain what we're doing here and who you are?
I'm Zara Wales, and I am Uriah Wales, and I am 7. And I'm Tavia.
Why don't you stand over there, Taves?
No!
Okay, so what are we going to do here with the popcorn?
We are gonna, grab it and put it and make sure and see which one can hold the most.
Do you think which one of those can hold the most? Which one do you think will hold the most?
The bottom.
Okay. All right. So let's spread them out, and then you can fill them up, and let's see which one fills up the highest, okay? So let's spread them out by size. Okay. Here you go. We'll put them next to the. Oh yeah, you gotta eat some for sure. So we're gonna put some in here. Oops. And then when it's full, you gotta.
Eat it.
No, Zara, dear. Okay, let's put it in there. See, when it's full, then we stop with this one. Okay.
Mm-hmm.
All right. Nope, you can't touch it. That's one of the rules. You just can't touch the pile. Okay, so that one, let's say that's done, huh? Okay, next one. Next one, let's put some in the next one.
Zara.
Grandpa should have made more popcorn, shouldn't he?
Don't rush it. And time Grandpa's little. We might have to say this one's close to done. That holds 1. And this guy can barely hold any. See? He only has that much in it. This guy is not winning. He's not very big, so it's not very useful.
So, did you get it?
Yeah.
Can you put any more in this one? Do you think? Well, let's take the popcorn out of this one, and let's see how much popcorn it is. Okay?
It is. Those are Zara.
No, not that one, Zara. Just this one. So it's 1 bucket. Let's see if it's 2 buckets.
It's probably 2 though.
Okay, well there's 1 bucket.
Way more than 2 obviously.
There's 2 buckets. Okay, let's put some into this bucket and let's see if we can get 3 buckets.
Can we do this?
Nope, just wait. Just wait, Zara, we're almost done. Okay, so how much is...
2.5 buckets.
Well, can you read the number exactly, what it says on there? For how much it is exactly?
10 ounces.
2 buckets plus 10 ounces. That was the big one. Okay, now let's try the medium-sized one and see how much. Oh, yeah, we can put more popcorn on that one. Let's see if we can get some more in there. Nope, that's all. So 2 buckets plus 10 ounces for the big one. Just wait, Tara. A little bit. We might be able to get a little bit more in there. Nope. Okay, now put it in there. So that's 1 bucket. Ooh.
Oopsie.
Oopsie. Okay, let's put it in the next bucket.
Oopsie.
Okay. So there's 1 bucket plus how much more for the second bucket, Uriah?
Let's see. That's the wrong area. I'm counting ounces, so 24 ounces.
1 bucket plus 24 ounces for the second one. So far this is our winner chicken dinner, right?
Yep.
This one is in second place. Okay, now let's see how much we can fit in this one.
This one doesn't have a good start.
No, it sure doesn't. Let's see if we can get some more on top of that. And not really. Okay, so let's see how much is in this one. Oops.
Sorry.
Put the popcorn back in the bucket.
Zara, load it down here.
So this one is almost exactly 1 bucket, huh? So we had 2 buckets, 10 ounces. 1 bucket, 24 ounces. 1 bucket. Okay, next size.
It's the little guy. He won't be able to hold much.
And this one we can get. How much could we get in this one, Uriah? Like, not even an ounce. 4 ounces, okay. And then we got one thing left because we can try just on the paper, and let's see how much we can fit on the paper itself. What's the matter? Okay, okay, now we've gotta, no, just leave it, because we gotta clean off the edges just so that we can get just the popcorn that's on there. Okay, so let's clean off the rest.
And
Put
this
it
is
in
going to be a sure lot, you
What?
know.
Taste.
Stay me hot.
Okay, start again. Katie, you can get down now. You are not as helpful as you could be. Okay.
I think that's all we can fit on this one.
Okay, so let's put the rest into the popcorn container.
And we'll just try getting all this.
Nope. Taste, please.
The bucket's going there.
Okay.
And these go here.
Yep, those go in there. I think that's it
For the avalanche.
for the avalanche. Yep.
And your students there are going to say, this one is Massey stick.
Okay, let's measure how much is on the cardboard. Get the bucket there. Is that 1 bucket?
One bucket.
There's 2 buckets. 2 buckets so far, man. We can maybe get more than 2 buckets, huh? 1 bucket.
And how much do we have for the other one?
It was 2 buckets and 10 ounces. So let's see if we can beat 2 buckets and 10 ounces. So you're eating part of the experiment. Okay, put it in the bucket.
And
2 buckets and 10 ounces so far.
girls, those weren't on the paper.
Yeah, they were. I got all the ones that weren't on the paper out of the way. Hey, what'd you get?
And
What does it say?
2 buckets, 20 ounces.
Okay, so let's go through them in order then. Which one was the most?
The paper.
The paper was 2 buckets and 20 ounces.
Then this dude.
Was 2 buckets and 10 ounces. 1 bucket and 24 ounces.
And
1 bucket. And where's the little one? This one was 10 ounces. So Zara, which one is the winner?
It's actually
Come over
4
here.
ounces.
Which one is the winner chicken dinner? Very good.
But it's the chicken
Okay.
dinner. That's
That-
We will
I'll
take our
eat
break.
that.
Okay, all right. When we come back, we'll start with page 193.
I'm not sure if I have one. Yeah, I do. Okay. Supposed to be really sad.
It's weird. Green. Yeah.
I was like,
Snitch on the information that was
Oh, I remember.
yeah. Because I was taking my test, I could just like vaguely hear it in my parents slowly.
I remember what too.
No. He like extended and was like, have you ever heard of the app Xbox? I was like, no. It's like, oh, it's a graphing app. We're using it. I love it.
Wait, how old is this person who's telling me that? How old? Why? I'm actually mad at this one. Well, for my assessment score, I have emails. So here? Wait,
Like,
do
I
you guys
don't
have
know.
that in class grade?
No,
What is it?
just like the first time.
Mine's like,
You should be better than mine.
exactly. Wait, what's yours? Yeah, mine's lower.
But you're here more than I am.
What?
I'm just like, I literally sat out there just to I couldn't in. Yeah, I was. I think it was 4.
So like, kind of this because like, should have that grade for in class. It's like only 2.
Well, right now math is my worst grade. Actually, no, probably around close. I don't try and stop it. I don't want to get off of these.
I have all the children that are
Yeah, but it's just
I don't know what one was
so it's just computer science because it says like in class.
I don't really die. There's no popcorn in fish.
Oh, like in class.
Experiment ourselves.
I'm doing it this time is
why is he doing it with video on computer class?
yeah, mine's too.
Because that's someone
So we have to get up probably the 16th.
So what's your issue?
You're old.
Oh, yeah. Oh,
Never had that.
Oh, yeah, I was working on it before class started, and I did not get done.
Okay.
So
and then
I'm in midstream right now.
it looks like you put in the test score, not the retake.
I haven't done anything. Well, I might have done the test score, but I'm not sure yet. I don't remember where I was in the process.
Yeah, I thought you said you were going to put in the retake. Yes.
I have not done anything yet.
Okay. Yeah,
So
'cause I saw that and kind of freaked out.
that's why you can't go by that. Don't. It's not accurate yet.
What is accurate?
Nothing right now. Because, well, I haven't graded your test. So I said I was about halfway done with grading the tests. So that's where I am. Halfway done grading the tests. I don't know how long I will be at halfway. I can guarantee it won't be done before 6 o'clock tonight, because
No matter what you did, like,
I've got to go buy food. Ooh, food!
One question, and this question, right? Yeah. That's because he's
Yep,
I
that's
love
how it
sleep.
is.
that's fine.
I like that too. I love sleep papers.
I think for me it takes a while because I always have to do the question on the assignment because I don't know what I'm doing. That's why it takes me so long. So like if you know what you're doing, you do it.
That research paper.
I don't know what the research
Well, we presented on the 7th. And I don't know when we have to give the conflict session.
I typed it in.
Well, because we have class Friday, so
I got so much in this. We're supposed to do like an informal
it's loose. I'm not gonna worry about it because she always says that to my brother.
So I'm like at work.
It's only 240 times.
I can't imagine how much I ate yesterday. I ate like a whole pound of things yesterday. Honestly, I was like, while I was watching my sister's how much. So it was kind of gross. This lady can 17 pounds in a bottle. And the doctor said for her to get 17 pounds in a bottle, she has to consume like 7,000 calories every day. I mean, that's kind of insane. Probably. No. Like, how did these remind me that all I do is just like love it. I wish I could do it. One guy who was so fat, he couldn't get out of the door, so he climbed up on the door. Like, in his call in his house, get him out. Most of these people have people who go out and buy it for them, but they can't walk. So they go to people that are like, yeah, I know what this is. Then this guy. So it's not like it was like 700 pounds. That's kind of bogus. And he's just
Megan, you said turkey for Thanksgiving.
That's the thing. Everything about me is so much this lady goes, and then this other lady was talking to her, just went through the browsing by the ass, and she was like, yeah, and I was like, she's going on 5,000 pounds. I would hate for my daughter to starve, and she wouldn't eat the possible food she would yeah, she's gonna starve. He must have been 500 pounds. My brother said it like that. Because I'm a big family.
I'm tired.
So then you have
I'm on the reason for traveling for like every show. Like,
how big are they?
paper out, I'm like, oh, so they have 3,000 calories in a day. I don't know, that's like, but I've never eaten so much. My sister said the other day, she was telling me about it last night.
All right, let's get started. So in our notes, I wrote down the volumes that the kids had for the different sizes. And here are the ones that they did. So they started out being an 8.5 by 11 piece of paper. Folded up 1 inch, folded up 2 inches, folded up 3 inches, folded up 4 inches. Why didn't we fold up 5 inches? Because if you start with a piece of paper, you don't pay attention to the long side, right? You pay attention to the short side. What's the most that we could fold up if it's 8.5 inches? 4 1/4, right? If we folded up 4 1/4, how much volume would it have? 0, right? Because this dimension right here, instead of it being a 1/2 inch that it is if it's 4 inches high, would only be 1/4 inch. Would be 0. So let's go through them and let's get the volumes of these boxes. Okay, so here, how tall? Oh, we got to make sure we know what we're talking about here. Here's our popcorn box right here, correct? Actually, you know what? It's even better if you use the one on the next page. So if you use the one on the next page, the actual volume, if you have a 1 inch cutout, is 1 inch. That's how tall it is. By, so if it's 1 inch tall here, how wide is it? Well, when this paper was flat, it was 8.5 inches wide. How did you get 6.5? Took 8.5 and subtracted 2 ones, right? And then how long will it be from here to here? Well, it was 11 long. Now how long is it? 9. And what do you get for an actual volume? How much?
58.5.
Do the other cutouts in your group get the volumes? Go. Anybody need help? So this was height, width, length. Each one of them you're going to have 3 dimensions, height, width, and length. What you getting?
We're figuring out this word.
You guys get them? No, I'm not even working on it.
I'm trying to get all the math homework done so I can enjoy my family.
And the problem is, if you don't pay attention in class, you get your homework done, but then when you get to the test, and there was something crucial in the test, like Kevin said, make sure you know what the right-hand behavior of a function is and how to get the correct sign.
Yeah, that's why I just don't do this.
What do you got? And the only person's fault that is yours, because Asking for help is not embarrassing. Not asking
Math
is.
affirmation.
I will not know how to do something today, but I will tomorrow. I will be patient with myself and others when learning math. Lauren, what do you get? What was your question?
Oh, I didn't have.
Oh, okay, I thought you did.
I know that's much. I think this is.
So what's the second one going to be? 2
Sorry, what do we get?
times.
The biggest thing I learned is my math affirmation.
Yeah, it's too tall.
Oh, okay. I see. I thought it was 2.32. So is that just 2 times?
Too tall. This one is too tall.
Oh, okay. I wrote this down.
How wide is it?
32. 32.
It was 8.5, but I took off 2 from one end and 2 from the other end. So now how wide is it? 2 from each end.
I think that's what it is.
2 by.
I can't do that.
So put in a 2.
The whole this stuff.
Put in a 2. Because that's the first number. Right here.
Right.
Right underneath that. So 1 was your first number. 2.
Yeah.
So how wide is it? It was 8.5. But we got 2 subtracted from this end and 2 subtracted from that end. So how wide is it now? 4.5. How long is it now?
Yeah, so I'm
Well, it was 11, right? But it's going to subtract 2 from each end, so it's down to
No, I think I messed up. Do I even know where these numbers
2 from each end.
Yeah, it would be.
So,
7.
starting.
Now look at your first number. What happened to your first number? It got
Is off.
1 bigger. So for the next one down, what will the first number be?
1.5 minus 2 times 2 and 11. 7. And then
Oh, I.
What will the first number be here?
Is that what that means?
3.
Yeah,
Correct.
X is help.
So your numbers, your first number goes 1, 2, 3.
Oh.
Your second number goes, yep, put in a 3. Your second number goes 6.5, 4.5, 2.5. Your third number goes 9, 7. And when you multiply that out, oh, you didn't multiply the last one out. 2 times 4.5 times 7.
I got it.
Yeah, I'm gonna eat my chips.
You know what you're doing?
I have. How do you get the middle part, Kevin?
Okay, did you copy down my table there?
I did.
Okay, copy down my table. So you took 1 times 6.5 times 9. Put the 2 first and then you'll see the pattern. Put the, just, you cross it off here. Yeah, just cross it off there and put it in front because I'm going to show you the pattern.
So for the 4th.
So 1, 2,
3.
3,
Oh my gosh. Came out of nowhere.
6.5, 4.5.
0.5.
5.
No. 6.5,
So
4.5,
2.5.
2.5,
So what fractions can we
9, 7,
5.
5.
Oh.
So
Okay.
0 times.
You see the pattern.
You see the pattern.
Like 0.5.
It goes 9, 7.
2, 3, 4, 0. This was 4.5, 2.5, 0.5. This was 9, 7, 5, 3. What'd you get for your totals?
Oh.
63. Exactly.
For the first guy.
Okay.
Well, it's the opposite.
Mathematical.
Let's take out Desmos and let's graph those. 0 was 0. 1 was 58.5. 2 was 63. 3 was 37. 4 was 6. Correct? For any x, the height will be x. The question is, what will be the width? (8.5) minus 2 x's, correct? Because there's an x on this side and an x on this side. What will our last dimension be? 11 minus 2 x's. We can graph that function. Volume I'm going to take this off here. Volume equals x times 11 minus 2x times 8.5 minus 2x. Now I'm going to set my window so that I go from 0. X goes from 0 up to 5. Now I went past, we can't have an x that's bigger than 4 1/4, we already said. But my y can go from 0 up to about 100, let's say. Okay, so there's our function of the box. What's the title of this section called?
Optimization.
So we want to optimize that box. In other words, we want to have it hold as much popcorn as we can. The popcorn will be maximized when the volume is at its greatest, correct? So, what do you see? The greatest is going to be at the point 1.585. So I had one of the students make a box that was 1.585 tall. This is the ultimate size of holding the popcorn. Now what she did first of all is she made it 1.585 centimeters tall, and I was like, dude, that does not look like 1.5 inches. And she said, I made it 1.58 centimeters tall. So does everybody agree, if this is 1.585 tall, it will hold the most popcorn volume-wise flat, okay? But the kids did not get those amounts. They got amounts bigger. Where did I put my boxes? Oh, there they are. They got amounts different than that. Oh, let's go through the questions. Just make sure we're answering the questions that are in the lesson. What is it? What's it say here? Consider represent the side length as x increases. As x increases, the volume increases for a little ways, but then after a while, the volume decreases. And in fact, by the time you get to 4 1/4, you got no volume left. So it's 0 at the beginning because it's got no height. it's 0 at the end because it's got no width. So on our notes here, where we graph those dots, we can see how the function fits in with that. Oops, I should have gone through 0 here at 4 1/4. I should have gone back down to 0. Use a graphing calculator or app, sketch the graph. How big should you make the X in order to maximize the volume of the box? What did we say? Did you graph it? No. Graph it. Everybody graph it? I'll put it up there again. Okay. Jean and Vanessa decide they are going to fill up the popcorn boxes with heaping portions on top of the popcorn that extend the mound over the top of the box. We can model the heaping portion by placing a pyramid on top of the box. Let's assume that the height of pyramid is 25% of the shortest side. Okay, here's where the book made a mistake. This is the shortest side, correct? 1/4 of that is this far. Okay? Can I stack the popcorn that much higher than the box?
Yeah.
Way more than that, right? In fact, maybe even 60%, maybe even 70% of the height of the box, correct? The only limiting factor is what this angle is. In your notes, extra stuff that you're learning. Angle of repose. For popcorn, if this is the top of the box, you can stack the popcorn about like this, correct? This is called the angle of repose. All right? That height is related to that length. Anybody take trig? Nobody? Yeah, what's the ratio there? Did you say tangent? You're absolutely correct.
Sure. I said, but yeah, tangent.
Tangent. Okay. This angle of repose is a real life thing. Now you may say, Kevin, you're just making that up. Here is a place where it's used. What is that piece of equipment? It is indeed a grain bin. Grain has an angle of repose. Oh, do you think water has an angle of repose? No. Angle of repose only works with solids. It doesn't work with liquids because their angle of repose is 0, right? They just spread out. So what they did is they designed these grain bins so that they are just the perfect angle. So become a farmer, because here on page 17 it says, where does it say it? The maximum cubic feet and cubic meters is based on a 28-degree angle of repose. So you can stack grain up to a 28-degree angle. Popcorn, do you think you can stack it just 28 degrees? No, because it's got all those multiple sides. Scientists have calculated what the angle of repose is for lots of stuff, not just grains. What's that?
The scientists are bored.
No, because they need to make sure these grain bins hold the maximum amount that they can. I'll show you another picture. So I was driving through western Minnesota, and I came upon this outdoor storage facility. Why? Because there was way too much grain to fit into their grain bins. Do you notice in this picture over here on the right, the angle of the roof compared to the angle of the soybeans inside? Do you see how the angle of the roof matches the angle of the soybeans inside? And in fact, they built this what do they call those? I was going to say buffer walls. That's not the right word. Anyway, they built that just the right size so that it would hold the side of the grain in, since they had to have a roof anyway. They would hold the side of the grain in, so you can see the angle of the grain matches perfectly the angle of the roof. Now, all of that is designed on purpose, exactly that way. They do not do industry for stupid reasons. They don't make like church steeple roofs, okay? Because that would be a waste of materials. They don't make the roof flat, well, for a couple reasons. One of them is the snow load would be just tremendous. But the other one is they need to maximize the amount of volume inside in order to have that stuff work out. So the part I don't like about our lesson is it says that the angle of repose is about 12 degrees or something like that. But it makes the math easier. Let's do the math on page 195. Modify your volume function to account for the extra popcorn. Okay, so we're going to have the volume of the box plus the volume of the pyramid. Now, in our notes, it doesn't say the volume of a pyramid, so we need to know what that formula is. One-third the area of the base times the height. So in our case, we've got a popcorn box. And we're going to call this area the base. What will the area of that base be? Well, it's going to be 11, let's do the 8.5 first. 8.5 minus 2x times 11 minus 2x. Everybody agree that's the base? And then it says the height here is 25% of the shortest side. And the shortest side is 8.5 minus 2x, right? So we're going to take that base times the height, 1/4, that's 25%, of 8.5 minus 2x. So here's our base, here's our height, and we have to multiply it by 1/3. Let's do some simplifying here. The volume of a pyramid as a function of x is, what do you get here? 1/12, right? What do you get when you combine these two? Two of them? No, not two of them. Squared. Good. Times 11 minus 2x.
Why is that squared?
Because I have an 8.5 minus 2x is the height, and I have an 8.5 minus 2x is part of the base.
Oh, alright.
Okay? So let's go to our Desmos again. And so we've got our volume here, which is going to stay, right? And then we're going, let's call it P of X for pyramid. So we're going to take that and add to it, right? Because it's the volume of the box plus the volume of the pyramid. So let's get the formula for the volume of the pyramid. 1/12 times 8.5 minus 2x squared times 11 minus 2x. So does it make sense? Does it make sense that when we add that pyramid, it's going to make our storage bigger? But does it make sense that the place where it gets bigger is shifted, right? Now it says our ultimate size is, well, if you click on any graph, it will always tell you the zeros, the peaks, and the other zeros. So you see the volume is still 0 at 4.25. How tall is a pyramid going to be if the box is no width? You can't put a pyramid in there, right? It's going to be down to 0. They say that you should get the most popcorn in when you are at 1.025. You saw the kids do their popcorn, correct? Did they get the most popcorn when it was 1 inch high? Well, it was certainly more than any of the other ones. But if you notice, compared to the flat actually had more popcorn in it than the tall one did. If we made this, where'd it go? If we made our graph so that our 0 would be here at 0, we could do that by changing this from 1/12. Instead of being a quarter as high, say it would be a half as high. Okay, then it would be up to 1/6. And if you notice, 1/6 is pretty close to where it should be. It actually might even be a little bit more than 50%. Let's say 60%. So we'd have 1/3 0.333 times 1/6. Ooh, that might be too tall. What did I do wrong? There we go, times 1/6. So if you notice, it might be 1/6 might be too much. Let's say 1/2 times 1/6 is 1/12. We already did 1/12. Anyway, you get the picture. So you could figure out how tall that pyramid would be. And remember, we're maximizing volume. Page. 157. They talk about strategies for factoring polynomials. We don't teach factoring in this class. Here's what we do instead. Desmos.
How did I know?
Let's check it out. Let's put in this equation right here. So we go to Desmos 13D. We go to Desmos and we put in V of X equals, I'm on page 198, 4x to the third minus 22x to the second plus 30x. I need to erase this one above it. So it tells me what my zeros are. My zeros are at 0, 2.5, and 3. So for the equation 4x to the third minus 22x squared plus 30x, we get zeros at 0, 2.5, and 3. How do we change those into factors? X 2x minus 5, because I rewrote this as a fraction 5 halves, and this one x minus 3. Now you could have written this as x minus 2.5, but they like to have whole number factors. Or you could use polysimal 2. Let's take out our graphing calculators. Polysimal 2. Step 1, it's a polynomial root finder. Step 2, it's the third order. Why third order? Because this number is 3. So I have to go over 1 to the third order. Next, I made a mistake. Polynomial, enter I should have pressed. Okay, so third order. Next, A3 is 4. A2 is negative 22. A1 is 30. And A0 is 0, because there is no constant term here. solve x1 equals 3, x2 equals 2.5, x3 equals 0, just like we got up here. So you go through the exact same process. We do not teach factoring. No, I want you to know you're not being cheated. And the reason you're not being cheated is we never get examples like that in real life. Remember that last lesson that we did where we were trying to find what the scaling factor was? And we said it was 4, or maybe we said it was 5. I can't remember now. We said it was 5, and it turned out it was 4.77. Okay? In algebra, they would say, well, don't worry about those. Okay? Now, if it's only a second degree, if it's a quadratic, there's one more thing you can do. Anybody know that one more thing? Quadratic formula. Now we'll use the quadratic formula later on in the class, but we are not going any deeper down that road. Lesson 14. Gallium is a metallic element that melts at about 85 degrees Fahrenheit. Suppose that a sample of gallium is brought to a very low temperature and then heated in such a way that the temperature of the sample in degrees Fahrenheit as a function of time is modeled by this function. Okay. First off, over here on the right-hand end, where am I going to be? Up or down?
Down or up?
You are correct. It is one of those two.
So up.
Because it's a
The first
positive
number is a
leading
positive.
coefficient. What am I going to do as I go backwards in time from ending up?
Down.
Keeping on going down. How many times am I going to turn directions? So I'm going to have a bottom. That's one turn. I'm going to have a top. That's 2 turns. I'm going to have a bottom. That's 3 turns, right? 3 turns. Okay, so I went 4 times. So over here on the left-hand end, since I bottomed out there, over here on the left-hand end, where am I going to end? Up. Okay? Here's a rule for the left-hand end. Let's talk about the right-hand end. If the leading coefficient is positive, we end up. If the leading coefficient is negative, we end down. Let's talk about over here on the left hand. If the power is even, it's the same. If the power is odd, it switches. So let's look at the one we just did for gallium. Gallium as a function of time. The only thing we're going to pay attention to is the leading coefficient, which is positive 1. And the power, which is, t to the 4th. So this tells us that we're going to end up This tells us we're going to do the same. Let's look back at the ones that we had before. This one right here. Leading coefficient here, well, -2 times -2 is +4. So eventually this graph is going to be going up. Eventually. We only went down to this spot right here, but eventually it's going to be going up. What's the power going to be? X to the third. Does that make sense? There's 3 factors. So over here on this end, it's going to be going down. How many turning points does it have? 1 here and 1 here. Go to this one right here. No, where was it? Oh yeah, the one that we did before, but I never finished it. What was the one where you guys, it was up 10? Do you remember? F of x equals something plus 10 was the last thing. 5 x minus x plus 1 x minus 1 x minus 2. So it ended up, that's because of the 5, and it ended down on this side because the highest power is 5x to the third. Got it? I think that's all we're going to get to. We'll start tomorrow on page 202.
Hey, Mr. Halkey, am I doing the retake here today then?
I can print one out for you, but can you wait and see till tomorrow? Because your grade was really good. I mean, you might not think so, but wait until I get your grade report done and then decide. Because I don't want you to waste your time. Nobody improved their score over what they got by the, I don't think so. I'm not positive yet. But I don't think anybody did extraordinarily better on the retake than they did with, you got to remember, the group test raises your score. You guys had, I think, 1 wrong or a half a wrong or something.
A lot wrong.
Yeah, but remember, they only count for half off each time, because if you scratch off the second one, you don't get it totally wrong, you only get it half wrong.
We'll just wait until tomorrow?
Yeah, wait until tomorrow, would you?
Alright.
I hope to finish it tonight. I worked. Luckily, the game went excitingly all the way to the end. Otherwise, I wouldn't have worked as long as I did last night. That was pretty awesome NFL game. Probably one of the best I've ever watched. You have time right now? Okay, why don't you come down to my office and I'll do it. Okay?
Bye, Kevin. See you tomorrow.
See ya. See you, gang. Who's talking to me? What did you say? The Colleen money is going to be must have 5 roots. No, at least.